again, dear students. I hope you are doing well and you are fine and safe. In this section 1.3 in your subject material linear algebra, you have a matrix and system of linear equation. So we have two important things here. I'm going to mention here. We have a Gauss and Gauss elimination, which means Roche-Echelon form, and we have Gauss and Jordan. This is our object for this lecture. First of all, we have what? We have a matrix of a system. Okay, dear. We have a matrix. How we build the matrix for the system? We have augmenting matrix, which means that in creating matrix with the equation. So here you can see that we have an equation like that. We have equation, such equation like, such equation like 2x minus y is equal to 5, equation number 1, and we have x plus 4y, okay, is equal to 7, equation, second equation. So we instead of solving this equation directly, we are going to change this one to the matrix. Okay, so like that, we have a matrix. We say 2 minus 1, 5, 1, 4, 7. That's the augmenting matrix, okay? And the matrix has got row, so first row, second row, and columns. So C1, C2, C3, okay? And the matrix also has got dimensions, which are called by R by C, or R by row by columns. In this situation, we have how many rows? We have say 2, so we say 2, 1, 2, 3 by 3. So we say that our matrix, for example, A is 2 by 3 matrix. We mean such matrix like that. Okay, dear. So here's the general formula of the matrix. You can see here is the general form for matrix. Okay, now the dimension you can see here also. Maybe you have a matrix dimension 2 by 3, you know, as I told you, maybe 1 row by 4 columns, which also sometimes called in the computer especially vectors. So now I have the matrix, linear matrix like that. So you can see we have 3, I'll put 3 here, minus 2, z is equal, the coefficient of z is equal to 1, so I'm going to write down 1. We have 5. Again, we have x, 1, y, 3, z, minus 1, 0. Now, look at the third one. We have what? We have minus x, which is equal to minus 1. There is no y. When I say we have no y, means that 0 y. The coefficient is equal to 0. That's why we'll put the 0, number 0 here. We have 4. We have 11 as a other part. So, try to also find the augmenting, as I told you, augmented matrix. Try to find the augmented matrix. Means that change the linear system to the matrix. That's all. Okay, augmented matrix. Okay, now how many operations that we have? So we have elementary, means that basically fundamentals. Row means that we are working on the row, not the column. On operations means that addition, subtraction, or scalar multiplication. Okay, we mean something like that. So we have addition, multiple row, okay, multiple row, or we have interchange the row. These three, we are working with just these three for solving such a system like that. And we have a Gauss, which we call sometimes as a Gauss method. So before we are going to use the such like operator, we say that, for example, I say R1 changed with the R2. For example, in that example, if I say R1 is changed with the R2, okay, it means that we use the third operation, which is interchange 2 rows. So in that case, your matrix, if it's like that, 1, 2, 3, 5, 2, 1, for example, 2, 0, 1. When I say R1 change to the R2, here, R1 interchanged with the R2, means that the matrix changed to such matrix like that. So the third matrix remains because we didn't mention anything about the third row. So that's why we just changed the 1, 2, 3, 5 to 1. So this is the operation, the third one. We say interchange. For the add multiply of one row to another means that we say R1, for example, okay, R1 plus 2R2, put it in where? Put it in R1. Here means that because we have now our or maybe you can say we changed this one. I wanna teach you about the second operation with the addition of or multiplying of such row together. So it means that R2 and R1, 3, they are constant, they are the same, they are fixed. So we will write down this one. Just R1 change it to what? R1 change it to something new. With multiply R1, we have R1, here's R1, multiply to R2. So if I multiply to R2, I will get what? 10, 4, 2. Then add, so R1 plus 2R2, add, okay, we have 11, 6, 5. So then put it in R1. So it means that the new row, the new things is like that. So when I say R1 plus 2R2, put it in R1, I mean such operator, such operation like that. Okay, dear? That's about the second operation. When we say that, just for example, if I have such, I'm sorry. So we mentioned the first operator. Now it's the second for the second time. If you have such a matrix like 1, 2, 3, 2, 4, 8, minus 5, 0, 2. Okay, we have a such matrix like that. When I say R multiply R2 by 1 over 2, I mean that the second row should be divided by 2. Maybe there's a comma. That's why the first, okay, and the third will not change. Should we write down again? Then if I divide by 2, I will get what? 2, 2, and 4. So that's again some multiplication the row by what? By such number. Okay, scalar, non-zero scalar. So that's the second row operator that we can use it here. So you have 3 steps like a chess. You have 3 steps. You have interchange. Okay, you have non-scalar multiply, for example, non-zero scalar multiply by such row, and you have what? You have R1 plus, for example, Ri plus some numbers R2, Rj, then put it in the Ri. Means that these operator we did it. Why we use these steps 1, 2, 3? Because we want to change this one to solve it. To solve what? To get such thing like that, like the triangle. Okay, we need to get the triangle matrix, as I said in the first system. We say the system with the triangle. Why? Because that later if I get some such, for example, 2 is equal to some number here, means that z is equal to like that, or the solution of the z. So before you are imagining things, you need to know, to understand about the Gauss. Okay, Gauss say any matrix you have, any matrix with any numbers. First of all, you can see this information. I'm going to in here. Okay, you can find it in the page 96. Okay, dear. He said that what? He said that try to change the first to be 1, here to be 0. That's your work. So first step, you will change this one to 1, the first. The second, you will try to change this one to 0 and 0. The second, you have this one to be any number, any. Here should be 1, because I left 2 here, and here should be 0. So 1, 2, 3, 4, 5. The fifth step will be like that. The third, here to be any, here to be any. That should be 1. Okay, So this is your steps. You try to change, use these three operator that you have, you allowed no more than this one, these three. You will try to convert this matrix to such number like that. How? I will tell you later. I'll solve the example for you with the solved example in page 95. Okay, so why I skip to the 96, because I am going to tell you the strategy, okay, to solve. And here's be any number, any, we don't care. So that's the strategy for solving the Gauss. After this one we have a Gauss Jordan, but here we have a Gauss, so please try to understand. And the Gauss has another name. We say row echelon form. Okay, that's why we say row echelon form. Okay, now I'm going to write down such example like that for you. We have X. I'm going to write the augmenting matrix directly. Okay, we are going to, I'm going to in the 95, page 95. Here's the matrix. Say solve the linear equation by using by solving, for example, use Gauss. During the exam, if I don't say anything, you can use any method that you like. But when I specified the method, you should follow. You should use it. Okay. So that's why very important to know about all the methods. So in here we have what? We have X, okay, minus Y, Z, 3Z is equal to 4. Okay, in the second we have 1, 2, minus 2, 10. Okay, the third we have 3 minus Y, 5Z. 5Z is equal to 14. So now it's time to follow the strategy. As I told you, to remember that this one should be 1. Try to be the second to be 0. The third to be in the first column, I mean, be 0. So now, how we change this one to 0? That's the idea. Here's, fortunately, we have a 1. If we haven't 1, we will use the interchange. How we change this one to be 0? That's the question. How we change this one? Which method I should follow to get this one to be 0? It's easy, I think. How? I say R2, we are going to change the R2, to 0. If I multiply minus 1 with the R1, I will get what? I'll get 0. How? Look at it. We have 1, minus 1, 3, 4. So R2, here's R2. Multiply by minus. So I'll get what? I'll get minus. So here's R2, 1, 2, minus 2, 10. I will multiply this R1 by minus 1. So minus 1, okay, plus 1, minus 3. If I multiply by minus 4. Right? Okay. Now add them. So I'll get what? I'll get 0, 3, minus 5, 6. Am I right? So you write down like that. 0, 3, minus 5, 6. That's the first method, first row. So we change this one to what? We change this one to 0 without changing anything. We just use that one. Now it's your turn. Tell me about R3. How we change R3 to 0? The same. R3 plus what? Minus 3R1. Okay. Change it into the R3. Now it's your turn. So we have R3. 3 minus 1, 5, 14. Okay. Here's 3. So minus 3. Multiply the first. Minus 3 plus 3 minus 9 minus 12. Am I right? So now again add them. You will get what? 0. I will get 2. We will get 4 by minus. You will get also 2. That's the second row. So we do we did two operation with the row in the one steps. Okay, you can do it. Then we will get what we get, the solution. You can see in your lecture note, page 93. Here's the by one, and you get this result. Okay, dear. Now it's time to what? It's time to see if there's a common here or not. Tell me. Can we divide this one by any number? No. Can we divide this one by any number? No. Can we divide this one by any number? Yes. By what? We can say by 2. So I will get what? If we multiply, we say what? We say 1 over 2r3. So it means that just change the r3. So I'll get 1 minus 1, 3, 4. Okay. 0, 3 minus 5, 6. 0, 1. Okay. What else? 0, 1. Minus 2, 1. Okay, dear. Here's the results. Better to do it like that. Now it's time to change what? As I told you, let me show you again. This one should be any numbers. Okay, we will try to, or focus to this element to be 1. Okay, we try to be 1. That's the our object for this step. So that's why we say what? We have R2, right? We want to change the R2. Okay. And we need to what? You can directly say with the R3, we say what? We say minus or plus minus 3R3, put it in R2. Maybe you ask me why we don't use R1. If I use R1, I'll get mistake. Why? If I use R1 instead of R3, okay, this one will multiply by minus 3. When we add with that one, I'll get what? I'll get minus 3. If you change this one again to any number, you did mistake. So please do not change. When you change this one to 1, this one to 0, this one to 0, it shouldn't be changed. You cannot control this one later. So that's why you don't try to change this one to any number. Your focus, I know it's on here, but when you focus in here means that this one should be fixed. You can't change. If you change it, means that you did mistake. Okay, so that's why I didn't say R1. So now I know if I put multiply this one by minus 3, we add, this one will not change. That's why we use the R3. So here we go. If I multiply R3, we have R2, 0, 3 minus 5, 6. This one should be better to not write this here. I'm doing it for you. If you, it's better to write in the other page or another place. So minus 3 with R3, I'll get 0. I'll get minus 3. I'll get minus 6. I will get what? Minus 3. Am I right? So this one should be plus because we multiply by minus 3. That's why. So now add them. You will get what? 0, 0. You can see this one changed to the 0. Okay. Why? Maybe you say it's better to change it to 1. I know you are right. You can multiply by 2 or minus 2, up to you. Or you can change this one to 0 and then later we change the R3. That's why I follow your book, because I want to show you also interchanging the row. So in that case, I'll get 0, I'll get 1, and you get 3. So 1 minus 1, 3, 4, fixed. 0, 1 minus 2, 1 is also fixed. We change this one to 0, 0, 1, and 3. Now I'm interchanging this one. Why? If I interchange it, R2 with the R3, I will get such like that. Such matrix, augmented matrix like that. 0, 1 minus 2, 1. Okay, 0, 0, 1, 3. In that case, we change this one all together. How? We have 1, 0, 0, 1, 0, 1. So that's our matrix that I told you. We need the triangular matrix. Now you get the solution. How? When you have 1 here, means that 1z is equal to 3. So it means that z is equal to 3 here. Okay. In the second here, means that 1y minus 2z is equal to 1. 1y and 0x, 1y minus 2z is equal to 1. And z is equal to what? Is equal to 6. which means that y equal to what? 7. So you get the 3 and 7. We solved this one before, you know, you remember. Now, how about this one? The other example, other value. Means that 1x minus 1y plus 3z is equal to 4. So you know about the y, we say x minus 7 plus 9 is equal to 4. And x plus 2, which means that 4 minus 2, x is equal to 2. Here's the solution. So you get the solution. The solution is that x, y, z was 2, 7, and 3. We solved this one before by the another method in 1.2. So that's why we use the Gauss to solve the system with another method. Okay, dear? I know it's a long, but it's not need no more work, but it's not difficult. You need work. So please try to solve exercise 19. It's better for you. Now we use the Gauss elimination. The Gauss elimination, as I told you, is the strategy to write such example like that. Okay, that's the also, as I told you, we have a row echelon form. You can see this example was easier for you. I'm going to solve this example on the page on your lecture notes without solving by myself. You can see step by step. We have what? We have 4 here. Our focus will be on the 4. So we divide this one by 4. You can see, divide by 4, you will get this matrix. Later in the second row, we try to change this one to 0, unit to 0. You can see your lecture is really nice and mentioned nicely for you. How we solve one? We solve, we say R2 minus 3R1, then at R2 minus 3R1. Then how about here? We say R3 plus 2R1. You can see you'll get the result. Do it at home. You see you get this one. How we change this one to 0 is easy. With the R3 we try to do something. Now it's time to see if there's a common or not. You can see this row can be divided by 2 and this one can be divided by 5. You can do it in your book. He didn't do it, but you can do it at the same time. You just do it here by 1/2. So you get this one. Now this one, why we get what? We get 1, 0, 0, 1. Now it's time to change this one to 0 without changing here. This one shouldn't change, right? We shouldn't change this one. So it's 5. How we change this one to for example 0? We say this one with that one. If I multiply minus 5 to the second row, I'll get a 0 here. So that's why we say R3 minus 5R2 and put in the R3, you got 0. So also you can see there's a common, you can divide it. Look at it. You can divide this one by 5 or by 10. It's better. You get such like that. Now it's our formula is triangle here and triangle there. So z is equal to minus 2. Z means that z is equal to minus 2. 1y plus 4 is equal to minus 7. How about 1x, 2y minus z is equal to 1, and you can find the value of what? Value of system. That's all. Now another step. If we add 2 more steps to the Gauss, we will get Gauss-Jordan. Okay, if we add 2 more steps in the Gauss, we will get Gauss-Jordan. How? I am going to tell you. We say before, we say this one to be any, but now we don't say to be any. We try to change, instead when we have a triangle here, we try to change these two to 0. It's not different which one is the first. So we try to change this to 0. Okay, then after this one we try to change this one, then later we will try to change this one to 0 again. So this is the first step, this is the second step for what? For Gauss-Jordan after Gauss. So we have a Gauss here, 2 more steps will change to the Gauss-Jordan. It's very easy. Now I'm going to solve this one for you by Gauss-Jordan. Okay, we solved that. Okay, we solved that before, I think. Yeah, we have this solution. Okay, we will start from here to get what? To get Gauss-Jordan. Okay, we have such matrix like that. After, for example, during the exam I say solved by Gauss-Jordan, so you do the Gauss, then later you will get the Gauss-Jordan. So here's the Gauss after solving. 2 minus 1 is equal to 1, 0 1 of course, 4 minus 7, 0 0 of course, 1 minus 2. So how we change this one, as you see in the example 4, you say try to solve this one. We did this one in the example 3. I got this one. Now it's time to change that one to the Gauss-Jordan. So this one is Gauss. We try to solve it as a Gauss-Jordan. Gauss and Jordan. Okay, dear? That's all about the equation. Our work, our job, will depends on what? Will depends on how we change this one to 0 or how we change this one to 0. That's all. So I'm going to try to the first one. I'll change this one to 0. So I say I should write down what? We have R2 as you know, right? So R2 minus what? R2 minus 4R1. Why R1? Because here's the 0, that's why. 4R1, okay, put it in the R2. Let me see what will happen. If we have R2, we have 0, 1, 4, minus 4. If I multiply minus 4 to here, I will get minus 4, okay. So that means that this one is not good. This one should be 3, right? This one should be 3, because if I multiply by R1, it's a disaster. Well, these all will change. So that's why, look at it, I'll change to 0. 4 to here 0, 4 to here 0, 4 to here by minus, I will get minus 4, 4 to here by minus, I will get 8. Am I right? So now try to add them, we will get 0, 1, okay, nothing changed, 0, 1. So put it in R2. So R1 is minus 1, 1, okay, 0, 0, 1, minus 2. So here will be changed to 0, 1, 1. Is that right? Yes. Here also fixed, and we change this one to what? To 0. Now it's time to change that one to 0. So how we change that one to 0? I know I need to work with what? With I should change R1, of course. R1 with what? R3. You can see here's the 0 0. That's the benefit of here. So I say R1 plus R3 and put it in R1. So which means that R2 is the same. I'm going to change what? To put R1. R1, we have R1. Here's 1, 2, minus 1, 1. Then plus with the R3. So 0, 0. So it means that here plus with there. So 1 plus 0, I'll get what? 1. 2 plus 0, I'll get 2, 2. Here plus here, I'll get 0. Here plus here, I'll get minus 1. So I got what? Also again I got 0 without changing anything. Look, here's not changed, here's not changed, also here's not changed. So we are in the final step with changing this one to what? To 0. As you know how we change this one, I think it's clear with the R2. So I have R1 minus 2R to put it in R1, of course. So in that case, 0, 0, 1, minus 2 not change, 0, 1, 0, 1 not change, the R1 just change it. So how we solve that one, how we use it? Multiply minus 2 here, so I'll get 0, I'll get minus 2, I will get 0, I'll get minus 2. Now add them, so 1 and 0, 1. 2 plus minus 2, 0. 0 plus 0, 0. Minus 1, minus, I will get minus 3. Okay, dear, that's all. We get minus 3. So in that case, we get the solution. How? You can see this one means that z equal to minus 2. How about this one? Directly means that y is equal to 1. How about that one? Means that x is equal to minus 3. So here's the solution. 3 minus 3, 1 and minus 2. As you saw before, we solved this one by Gauss. We get the same, but one more step. And when you change the matrix from Gauss to Gauss and Jordan, we get what? We get the same result. Nothing changed because the same system. That's why Both of them, they are very important. You should learn about how to use Gauss-Jordan and how to solve Gauss-Jordan after all these techniques. Don't forget about these steps, then later that one. And here's about the 98. Please try to solve 23 in your exercise. As you know, maybe we have the same situation. Maybe you have one solution as we solve it here. One solution like that as we solved it before. Maybe we get something like that. No solution. Why no solution? Means that 0 is equal to 1. 0x, 0y, 0z means that 0 is equal to 1. So in that case, you know, we have no solution. Maybe after using the Gauss and Jordan, we have infinite solution. How? We get such number 0, 0, 0 is equal to 0, means that 0 is equal to 0. You know that's the method. So for understanding how I get such a solution with using Gauss-Jordan, I am recommending you as a homework example 5 and example 6 will help you to answer the question how. In that question, you can see we have this linear system. So we change it to the augmenting matrix. We use these two operation systems. You can see here in page 100. Okay, you can see here's the augmenting matrix. We used these steps, as you know. We changed to the Gauss. Can you see? We changed to the Gauss. Now we have 0, 0, 1, which we try to change this one to 0. When we try to change this one to 0, we got something like that. So which means that 0 is equal to 18, which means that has no solution. Okay, which means that has no solution, the system. How about example 6? Which is the same, is not difficult. We have a system, we have an augmenting matrix. We will look at here. Look, we change to the R1, interchange to the R3. Why? We have already 1. Why I should change to anything? We divide something. So I change this one to here, and I got this method. So I'm trying to change this one to 0. I got such like that, and here's 1. We'll try to go to be 0. During the work on this row to be 0, I got such like that. So which means that it has infinite solution. Okay, means that has infinite solution or many solution. That's all about this chapter. And try to look at this example 7. It's not difficult, but it's okay, just for information you can look at here. Forget about page 102. Forget about modeling system. Okay, it's not included for this semester. So that's all about the 1.43. See you in the next video for discussing and understanding what about 1.4 and what we have. Have a nice time. I hope you are understanding